In episode 55, titled Seasonality and Granularity, Fixing Wrong Timescale Analysis, the focus is on aligning your timescale to reality so that your results make operational sense. Many analytic failures are not caused by sophisticated statistical mistakes. They come from looking at the right data on the wrong cadence. When the timescale is misaligned, you can miss meaningful peaks, mistake normal cycles for anomalies, or average away the very behavior you are trying to understand. The exam cares because timescale choices affect validity, interpretation, and model evaluation, and scenario questions often include time cues that signal what cadence is appropriate. In real systems, especially security and operational environments, time is a driver of behavior, not a neutral index. So your analysis must respect how processes repeat and how decisions are made. Once you internalize this, you stop treating time aggregation as a convenience and start treating it as a core modeling assumption. Before we continue, a quick note. This audio course is a companion to the Data X books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series.
Seasonality is a repeating cycle that influences outcomes, and it is one of the most common reasons a naive analysis seems right statistically, but wrong operationally. A seasonal pattern can be daily, weekly, monthly, or tied to business events, and it produces predictable rises and falls that recur over similar calendar periods.
The key is repetition, because seasonality implies that variation is not random noise. It is structured behavior tied to schedules, habits, and system load.
In security monitoring, seasonality can appear as weekday-heavy activity and weekend dips, or as end-of-month reporting spikes, and treating those as anomalies wastes attention.
In business outcomes, seasonality can appear as holiday demand surges or periodic billing cycles that shape user behavior. The exam expects you to recognize that seasonal cycles can masquerade as trends or effects if you do not control for them, which is why seasonality is a foundational concept rather than an advanced one. Granularity is the time resolution at which you measure, summarize, and model, such as hourly, daily, weekly, or monthly, and that determines what patterns you can see and what noise you amplify. Fine granularity, like hourly, captures short spikes, rapid changes, and operational volatility, but it can also contain lots of random variation that makes interpretation unstable. Coarser granularity, like weekly or monthly, smooths volatility and makes longer-term trends easier to see, but it can hide brief but important incidents and can blur cause and effect timing. The exam uses granularity as a subtle test of judgment because the correct answer often depends on matching the time resolution to the decision that will be made. If the decision is operational and immediate, overly coarse aggregation can be misleading, while if the decision is strategic and long-term, overly fine aggregation can exaggerate noise. When you define granularity clearly, you are acknowledging that timescale is part of the model, not an afterthought. Wrong granularity can hide peaks or exaggerate noise, and learning to spot that problem is a core analytic skill. If you aggregate too much, a short-lived spike can disappear into an average, creating the false impression that nothing unusual happened, even when a brief event was operationally significant. If you aggregate too little, normal jitter can look like instability, leading you to believe the system is chaotic when it is actually stable at the decision horizon you care about. Wrong granularity can also distort seasonality, because a weekly cycle can look like a trend if you sample at the wrong points or if you compare uneven windows.
The exam may describe a situation where an analyst concludes a control failed because daily outcomes fluctuate wildly, when a weekly summary would show stable improvement. When you narrate wrong granularity risk, you are warning that the picture can change dramatically when you zoom in or out, and that the correct zoom is driven by purpose.
Choosing an aggregation level should be based on the decision horizon and actionability, because the point of analysis is to support decisions that occur on a certain cadence.
If an operations team can respond within hours, then hourly or near real-time aggregation may be appropriate, but the evaluation should still respect daily cycles so you do not chase predictable peaks.
If leadership makes decisions weekly, then weekly summaries align to that cadence and reduce the temptation to overreact to daily volatility.
If budgeting and policy decisions are monthly or quarterly, then coarser aggregation may be the most relevant because it reflects the planning horizon and reduces short-term noise.
The exam often tests this by describing who is using the result and what they will do with it, which is the clue for selecting the appropriate cadence. When you align aggregation to actionability, you reduce false alarms, and you make trend interpretation more meaningful because it is tied to real operational rhythm.
Calendar features are a practical way to represent seasonal structure, so models and analyses do not confuse predictable cycles with unexplained variance. Day of week captures weekly rhythm, month captures longer cycles, and holidays and events capture special periods that can produce behavior shifts beyond normal weekly patterns. These features matter because they allow models to attribute variation to calendar context rather than to unrelated predictors, improving both accuracy and interpretability. In many operational datasets, a large portion of variability is explained by the calendar alone, and ignoring that forces the model to invent explanations from other features, which can create spurious importance. The exam expects you to know that calendar effects are legitimate features, not cheating, because they reflect real drivers of human and system behavior. When you narrate calendar features, you are also implicitly stating that seasonal adjustment is part of fairness in evaluation, because you should compare like periods to like periods. Seasonality is rarely identical across segments, so comparing patterns across segments is essential if you want conclusions that generalize beyond one region or one population. Different regions have different holidays, working hours, and usage patterns, and even within a single organization, different business units operate on different cycles. A model trained on one segment's cadence can misinterpret another segment's normal behavior as anomalous, simply because the seasonal baseline differs. The exam may hint at this by mentioning multiple regions or different markets, and the correct reasoning is to either model segment-specific seasonality or to include features that capture regional calendar context. Segment comparison also helps you identify where drift or policy changes affect cadence differently, because a change might alter one segment's seasonality while leaving another unchanged. When you describe segment-specific seasonality, you are showing that you understand seasonality as a contextual pattern, not as a universal constant. Time zone and timestamp consistency is a practical prerequisite because mixing time zones or inconsistent timestamps can manufacture seasonality artifacts and destroy the validity of temporal comparisons. If one data source records timestamps in local time and another records in coordinated universal time, then joining them can shift events across days and misalign peak hours, creating false conclusions about when behavior occurs. Inconsistent timestamp formats and daylight saving transitions can also create apparent spikes or gaps that are not real behavior changes. The exam often frames this as an integration issue, and the correct response is to normalize timestamps to a consistent reference and document the transformation. This is also why time-based grouping must be explicit about time zone, because a day depends on the clock you choose, and that choice should match the operational context. When you narrate time zone handling, you are emphasizing that time is a measurement system, and measurement systems must be standardized before analysis.
Irregular intervals add another layer of complexity, because not all systems produce data at consistent cadence, and missing time points can be mistaken for real drops in activity. Resampling conceptually means choosing a regular time grid and then aggregating or interpolating observations into that grid, so you can compare like with like across periods.
The key is that any resampling choice introduces assumptions, such as how to treat missing intervals, how to allocate events that span intervals, and how to handle bursts.
The exam may not require implementation detail, but it expects you to recognize that irregular sampling complicates trend and seasonality analysis, and that you should document how you made the data regular enough to analyze.
Documentation matters because different resampling rules can produce different apparent patterns, especially around peaks and holidays.
When you describe resampling, you are framing it as a modeling choice that must be transparent and justified.
Validation must respect time periods rather than random mixing when seasonality and time dependence exist, because random splits can leak future seasonal phases into training and make performance look better than it will be in deployment. A model evaluated with time-aware splits is tested on later periods it has not seen, which reveals whether it handles seasonal variation and whether it generalizes across cycles. This is especially important when the model will be used prospectively, because the real task is to perform on future data, not to perform on a shuffled sample that shares the same seasonal distribution. The exam often rewards time-based validation choices when the scenario includes seasonality, drift, or policy changes, because those conditions make random mixing misleading. Time-aware validation also supports better error analysis because you can see whether the model fails systematically during certain seasonal phases or event periods. When you narrate time validation, you are emphasizing that honest evaluation must match how the model will live.
Communicating seasonal expectations is a practical leadership skill because it prevents false alarm investigations and helps teams focus on true anomalies rather than predictable waves. If a team expects flat activity, but the system naturally peaks on Mondays, those Monday peaks will trigger unnecessary escalations unless you set the correct baseline.
Communicating seasonality also helps interpret model outputs, because an elevated risk score might be normal during a seasonal surge and should be compared to seasonal peers rather than to the annual average.
The exam may phrase this as preventing alert fatigue or improving operational decision quality, and the correct reasoning is that seasonal context is part of the explanation for observed variation.
This communication should include what cycles are expected, how large typical swings are, and which deviations are meaningful beyond that baseline.
When you do this well, you convert seasonality from a source of confusion into a source of predictable planning.
Choosing the right granularity from scenario constraints and goals is ultimately a judgment exercise, and the exam expects you to justify the cadence rather than guess. The constraints include data availability, measurement frequency, and the speed at which actions can be taken, because there is no value in modeling hourly if the organization can only respond weekly. The goals include whether you are detecting anomalies, forecasting demand, measuring intervention impact, or allocating resources, because each goal has a different sensitivity to peaks and noise. If you are measuring a program's effect, you might choose a cadence that captures a full seasonal cycle to avoid confusing the effect with the calendar, while if you are detecting intraday attacks, you might choose fine granularity but with seasonal baselines and guardrails against overreacting. The exam often presents multiple plausible cadences, and the correct answer is the one that aligns with the decision and the system's behavioral rhythm. When you can articulate that alignment, You demonstrate competence that goes beyond rote definitions.
A helpful anchor memory is match cadence to behavior, then model confidently. Cadence refers to the time scale you use, behavior refers to the real-world rhythm of the process you are studying, and matching them prevents misinterpretation and wasted effort. If the behavior is driven by daily human schedules, you need daily aware modeling and evaluation. And if it is driven by weekly business cycles, you need week-aware comparisons. The anchor also implies that you should not treat cadence as a parameter to tune after modeling. It is a foundational choice that shapes everything from feature design to validation.
The exam rewards this anchor because it leads you to consider seasonality, time zones, and segmentation before you trust any trend.
When you follow the anchor, your results become easier to explain and easier to act on because they reflect reality's rhythm.
To conclude episode 55, pick one cadence and justify why it fits, because that is how you demonstrate that granularity is a decision tied to purpose. Suppose you choose weekly aggregation for evaluating a security awareness program's impact on risky click rates, because the organization reviews program outcomes weekly, and because weekly summaries smooth day-to-day volatility while still reflecting meaningful behavior change. Weekly cadence also helps control for day-of-week effects, reducing the chance that a strong Monday or weak weekend dominates the conclusion, and it can capture full cycles in a way that supports fair before and after comparisons. You would still monitor daily behavior for operational surprises, but for program evaluation and leadership reporting, weekly fits the decision horizon and improves interpretability. This justification shows that the cadence choice is not arbitrary. It is matched to how the system behaves and how decisions are made. When you can defend cadence this way, you are fixing wrong timescale analysis at the root rather than patching its symptoms later. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.